Hi everyone, welcome to Moscan. So in today's video, we have been given one question in which two voltage controlled current sources are used whose transconductance GM1 and GM2 is given to us. Apart from these two voltage controlled current source, there are some R and C combination used in this circuit and we have to find the V out upon V in S domain. So we need to calculate this, so let's start solving this question. If you look at this circuit, for any circuit which is having a voltage controlled current source, we can write equation of I would be equal to Gm into V plus minus V minus. This is how we can represent the current for any voltage controlled current source. Now if I have to write current here at this node, so that would be equal to Gm1 time V plus minus V minus, and V minus is V in here. So this is the amount of current which will flow from this path. Now if I have to write the current equation which is flowing in this path, so that can be represented by V in minus V out divided by 1 upon SC. 1 upon SC is the Laplace transform of this capacitor. Now there won't be any current going inside this terminal. This will be zero current. So now we know the three currents. One current 0 which is going in this terminal, one current which is coming out from this terminal, and one current which is flowing between V in and V out. So we can apply KCL at V out. So what it will be? We can directly write GM1 V plus minus V in. This is the current which is flowing from this path to V out. Since there is no current which is going inside this, so all the current which is coming from this path is traversing in this path. So this would be equal to negative of V in minus V out into SC. 1 upon SC is there, so it will get multiplied here. Now, if you see here, since this node is as ground and this, there is not any current going in this terminal. So if I have to write the current here flowing from this terminal, the value of this current will be equal to Gm2 into V plus minus V minus. V plus is ground, so 0 minus V negative. V negative is V out in terms of voltage. So this current would be equal to minus Gm2 into V out. Now again, there won't be any current going in this terminal of this voltage controlled current source. So entire current will flow from this RC structure. So since this is the amount of current which we have calculated, so if I have to write the voltage here, this voltage would be equal to this impedance into the current which we have calculated. So let's call this as VA potential. So if I have to write VA potential, that would be equal to, since R and C are in parallel, so R into 1 upon SC upon R plus 1 upon SC, and this would be equal to R upon 1 plus SCR. This is the impedance which we have calculated just now, and this will get multiplied with this value of current which GM2 V out. So this is the voltage which will be here at VA. Now we have calculated the value of VA, and this VA value is nothing but the positive potential, which so far we have not kept anything in this equation. So if I put this value of VA, this is nothing but V plus value. If I substitute this V plus value in this equation, let's see how this unfolds. So I can write this equation now equal to Gm1 V plus is nothing but minus of R into Gm2 V out divided by 1 plus SCR. So this is the value of VA which we have calculated, minus V in was anyways there, and that should be equal to minus of V in SC plus of V out into SC. So this we have calculated now. Now we need to differentiate V in term and V out term. We need to separate these two terms so that we can calculate the transfer function that would be equal to V out upon V in. So let's multiply this term. So we'll get gm1 into gm2 into r upon 1 plus scr into Vout, this we will get here, minus gm1 vin, and here anyways we have vin sc plus Vout sc. So let's bring Vout term together on the left hand side. So we will get minus of gm1 gm2 into r upon 1 plus scr. This Vout term will also come here, so we'll get minus of sc. Similarly, if I take vin as common, so I will get minus of sc plus gm1 because of this term here. If I take negative Vout as common, so negative Vout upon, let's say if I take negative common, so I will get negative of vin. The negative will get cancelled out, and finally I will get sc minus gm1. This is this term, and this whole term will get divided here. So I will get gm1 gm2 r upon 1 plus scr plus sc. So this is the transfer function value. I can simplify it further. So we will get Vout upon Vin is equal to sc minus gm1 into 1 plus scr, and at denominator we will get gm1 gm2r gm2r plus sc into 1 plus scr. So this is the value of transfer function which we will get for this circuit which was given here. So in terms of calculation, it was easy, only we had to apply KCL and all. But how we are approaching, how we are writing this equation of current equation and how we are applying voltage equation, that was important aspect of this question. Hope you might have learned something new from this question. If you found this video useful, please share with your friends. And if you haven't subscribed to our channel, please do subscribe.